So let me record. Okay. So again, if you don't want to be, I'm just going to post this to my YouTube just so for anyone that can you can look back on this if you need to. So if you don't want to be heard whatsoever, just don't say anything. It should only be recording me though. So don't freak out. But if for say your little sister starts freaking out, you have to take care of her. That's okay. If your dog goes fast and pukes all over, you have to clean it up. It's okay. You can come back and watch this lesson on YouTube. Even if you're just a person that needs to see something 5 times to be able to understand it, I will still be posting the videos to YouTube. I'm just trying to record them in Zoom so that I'm not still spending a bunch of time recording lessons that I'm still teaching in class. Okay. So we're starting with 4.5. This is simply graphing sine and cosine functions. So we're going to get as far as we can today. And as far as we can, will just be as good as it gets. We will probably stay on 4.5 the whole week, which sounds kind of ridiculous, but it'll likely take us the entire week to get through the entire 4.5. Honestly, it could take even longer than that. It's a really hard section. This entire section as a whole can just be a lot to handle at once. So what we're going to do is break it down part by part. So each day we'll do a different part, and then we'll put them all together in the last day. So it will for sure take us this entire week, and then likely even a couple of practice days in the next week. So I'm going to first show you what we call the parent function of cosine and sine. So what I need you to do is draw a big, whatever that looks like. So it should be super long in one direction, right? Super long in the horizontal direction. And then we only need a little bit of that y-axis. So we need a short y-axis and a long x-axis. Same thing with our cosine. Short y-axis, long x-axis. Okay. I'll let you get that drawn up really quick. If you don't want to talk, but you have a question, feel free to type it in the chat too. And then I can go ahead and answer those. Okay. So the first thing about both of these is they only go up to 1 and down to -1. Again, this is the parent function. So when we're graphing these, there's nothing multiplied by them, there's nothing divided by them, we're not adding anything, we're not subtracting anything, we're not touching these functions at all. This is just like if you were graphing just x, or x squared, or x cubed, or the square root of x. It's that parent function without altering anything. So we go up to 1, down to -1, up to 1, down to -1. Our cosine and sine function, actually, both of them are very alike with some very small differences between the two. We'll talk about those two small differences kind of while we're going through these. So the way that we break up these intervals. So each function has about 4 intervals on them. And that's a full period of a function. So a full period of a function is where I could take that chunk, copy and paste it, and make the rest of my function over and over and over. Sine and cosine, all trig functions are repeating functions. So they repeat the exact same over and over and over and over. That's why we have such a long x-axis, is because this function hangs out on the x-axis. It kind of has that curve and just keeps going and going and going and going and going this way. It will never go up any higher than 1 or down any lower than -1, but it will continue to negative infinity and positive infinity. So we need to figure out the intervals that these lie on. If you kind of remember back to that trig activity, it has all trig values for this x-axis. So we start out with 1 pi over 2. And you essentially get to count your way up. So this was 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2. And then I ran out of room, so we'll just stop there. Oh, you can't even see my 6 pi over 2. So the one thing is, though, I want to be able to simplify all these down. I don't like to have a 2 pi over 2 or a 4 pi over 2 or a 6 pi over 2. I like to simplify these fractions down. So I know 2 pi over 2 simplifies down 2 pi. 4 pi over 2 simplifies down to 2 pi. 6 pi over 2 simplifies down to 3 pi. But it's showing you that you truly can take that one number and just kind of count up from there. In the opposite direction, we have those exact same values. So negative pi over 2, negative pi, negative 3 pi over 2, and so on. Okay, so we go in both negative and positive directions with the same intervals. So cosine has the exact same intervals as sine does. So we also have pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. Okay, same thing in the opposite direction. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. We'll go one more, negative 5 pi over 2. So when you try to draw out sine and cosine functions, I typically like to see about 2 periods of that function drawn. Sometimes you're only going to have 1 period, and that's okay. But I'd like to see at least 2. And on the test, I'll pretty much require about 2 periods of that function. So here's the one difference. Sine starts down. When I say it starts down, that means it starts at 0, 0. And the reason this happens is you can think about the unit circle. I don't know how far you can see here. But at the point 0, okay, at this point 0, your cosine value is 1 and your sine value is 0 because it goes cosine, sine. If you're thinking back to the unit circle, at this value, right, this is basically like the starting point of our unit circle. And this is the starting point of our graph. At that starting point, our cosine value is 1, our sine value is 0. So sine will always start at the y value of 0. Cosine will always start at the y value of 1. Okay, so sine starts down, cosine starts up. They will always have that same starting pattern. From there, they take the same form of a curve. So they both have that just curved wavy function. But sine from here goes up, down, all the way down, back up. That in itself is one full period. So one from here, up, back to the middle, down, back up. Okay, that one chunk of a curve is a full period of a sine function. For a cosine function, we start up. So our second point is down. The third is all the way down. Fourth is back up. Fifth is all the way back up. So this one is more like a valley, or like a little V there of how that function runs. Okay, so if I continue this pattern on though for sine, it would go down again, back through here, back up and back down. Same thing over here. It would continue going like that curve. Cosine would continue its curve as well. And this one would continue its curve as well. So while they look like the exact same curve, despite the fact that I really suck at drawing, I'm super sorry. Like despite my awful drawing here and that like some of these are pointed and some are like way curved and a little bit higher. If you were to graph these out in Desmos, you can see they look really, really close to one another. They have the same curving function. It's just the placement of those curves. It's almost like you took this one and you rotated it back one notch, where that highest point is at 1, or this one you rotated maybe 1 forward, where that highest point is at pi/2. Okay, so I'm going to give you a minute. What I need you to do is like put big stars next to these. These are going to be like your home base graphs. Every single time from here on out that we make an adjustment to this graph, we're going to continually come back to these graphs to make sure that we take a look at these and say, well, what's changing about the function? Say I gave you like 1 + 1/2 sine x divided by 2 + 3. And I asked you to graph that. You would take all those different numbers, come back to this normal sine graph and say, well, what does that +2 do to it? What does it divided by 2 do to it? What does it multiplied by 1/3 do to it? And you make the adjustments to this like home base graph. It's technically called a parent function, but you need a nice, big, accurate graph of what a normal sine and a normal cosine function looks like. Okay, so take another like 30 seconds to make sure that you have that entire graph down with all of its different coordinates and all of the different intervals. And type any questions if you have them. Okay. Now I'm going to show you, gotta get my chair back over here, something on Desmos. Okay. So let me share my screen. Okay. Nope. Here we go. Okay. So currently I have a normal sine function up on Desmos. So the one thing about Desmos that I don't love, and I wish it would change this, is when I'm graphing a trig function, I actually have to click on that point to get the fact that it's like right here, to get the fact that it is pi/2, 1. I don't like that they don't number their x-axis in trig values, but you can still get the points by clicking on that. So again, pi with 0, 3 pi/2 with -1, 2 pi with 0, and so on. So the first adjustment we're going to make, remember, when we're graphing these, like this is the most basic one you will ever see. I will never ask you to graph a normal sine function. From here on out, we're going to take one thing and change it. So the first thing we're going to change is by taking our normal sine function and multiplying it by a number. Okay, this number is called your amplitude, and I'll write all this down for you in just a second. But this amplitude changes our function in one specific way. So I'm going to put a different number up here. You see how that changed it? So now we're only going up to 0.5 and down to 0.5. Let me give you another one. Let's go 9. No, that's way too big. Let's not do that. Let's go 7. Jeez. Let's go 5. Oh gosh, even still big. But see, it goes up to 5, down to 5. So essentially, can we all gather that this front number right here that I just highlighted, anytime I change that number, this is the number of how far I go up and how far my function goes down. Okay, it's like we're hitting that horizontal asymptote at 5, horizontal asymptote at -5. We put these restraints on our function. This number highlighted, this 5, is our restraint. Again, we change it again, 1/3, we can only go up to 1/3, and we can only go down to 1/3. So we put this restraint on our function here. Okay, so I'm going to stop screen sharing, and I'm going to give you some notes here to go along with that. Okay, because there's some specific language we want to be able to, in terminology, we want to use here. So, sorry, I took my shoes off. I got a little too comfy sitting down there. So let me erase this. That number out in front has a name to it. Specifically, we would say that this is a sine of x or a cosine of x, in which a is that value that's out in front being multiplied by it, okay? A is actually called the amplitude. So a word that I'm sure you've heard in math at some point in time before, or even maybe in science or something. I wrote that super small. Sorry, I'll write it a little bit bigger. Again, A stands for amplitude. So the one thing about this A is we always want to take the absolute value of it. So if I had, like, let's say a -5, I can't go up to -5. I can go down to -5, but I can't go up a value of -5. So truly this A value is the distance away from your x-axis. So we want to take the absolute value of that. So it wouldn't be -5, it would be the absolute value of -5, which is actually +5, right? So if this A value is greater than 1, meaning it's a whole larger, that's a number that's not a fraction, basically. Well, it could be a fraction, it could be 5/2, but it's got to be a fraction that's larger than 1. Then it stretches the graph. You saw when I put that 9 up there, it made it just like, whoop, stretch way out. And then also, if we have an A value that's less than 1, meaning it's a fraction smaller than 1 or a decimal smaller than 1, it shrinks it. You also saw this when I input some of those fractions. This one made it so it was like just barely a curve up and down, up and down, up and down. While as when I had a big A value, it was like, woo, let's stretch it way up and way down. Right? Okay. The one thing I need you to do for me, we have just a couple more minutes left here. What I want you to do is, it's not that hard of a thing. This is for your own notes too, and we can kind of go over this tomorrow. I want you to graph the following functions for me and bring it back tomorrow. I showed you mostly what happens with a sine function. So I want you to go ahead and graph. Let's have 3 cosine of x. Keeping in mind, it's the exact same cosine graph, only you go up 3 and down 3 on that y-axis now. Okay, do you guys think you can do that? Yay. Okay, I'll stop recording really quick.